degree, 2 degree, 1 degree. In SN2 it is 1 degree, 2 degree, 3 degree. Sir, SN1 is a single, SN1 is two-step process, SN2 single-step process. And sir, for SN1 depends on stability of carbocation, SN2 depends on transition step. Then SN1 having racemic mixture, 50% dextrorotatory, 50% levorotatory. And here, this one. SN2 is having inversion of configuration takes place, is known as Walden inversion. And both in SN1, both side attack is possible, but here only backside attack is possible.
Okay, thank you very much. So difference we got to know. So I am just asking which will question is there, which will give faster SN1 reaction, faster SN1 reaction. No, this is the question. Which will give faster SN1 reaction? Faster SN1 reaction. The question is here Cl is there. This is Cl is here. Cl is there. Cl is there. So there are four options are there. A, this is B, this is C, and this is D. They are asking which will give faster SN1 reaction. Faster SN1.
Faster SN1.
What is the order of reaction of SN1 reaction? Just now you told me.
3, 2, 1, 3, 2, 1, sir.
3, 2, 1. So which one can be? Can you guess?
3, 2, 1, 3, 2, 1.
But these are the objective question. Now you have to
Sir,
answer.
answer will be D. D. Answer is D.
Option is D. Very good. Thank you. So let me go back and just take a book I am taking. Just a minute. See, the questions are there here. Example is there. This example 10.6. Okay. This is 10.6. Is it visible to you? Sannoy?
Sir, nothing more is visible, sir. Only last question is visible.
Last question only. This one is visible now. 10.6.
No, sir. No question. Anything is not visible.
Any PDF file is not visible to you?
No, nothing.
I shared the screen here. Wait. Now is it visible? Question number 10.6. Can you see this?
Yes, sir.
Hello?
Now I can see example 10.6.
Okay. What we have to do, we have to do these questions. In the following pair of halogen compound, means here is the 2 pair is there and this is also 2 pair. Which would undergo SN2 faster out of these two? The first one you tell me, that is, which one will undergo faster SN2? Whether this one, first one, or the second one? Faster SN2. What is the order of SN2 reaction?
You can scroll a bit upward, sir.
If I will scroll upward, then the answer will be there.
Oh, achha. Just 1 second. 1, 2, 3.
What is the order of SN2 reaction?
Second
SN2
one, second.
reaction.
Achha, SN2 first one.
SN2 you are saying first one. Why it is first one? Why not second one?
Sir, because in the second one, sir, the less number of carbons are there. No, sir, that is why.
Less
No,
number
sir.
of
In the second one, this is Cl will be attached to one carbon, which is attached to two carbons. So it is 2 degree. But in the first one, we have only 1 degree. So that is why.
Okay, very good. This is 1 degree and this is the 2 degree. Now see, for a given alkyl halide, reactivity of the Rx follow the same order in both the mechanism. Highly reactive is Ri, then RBr, then RCl, then Rf. Means the Ri is faster, good leaving group. I is large size, so weak bond, so it will break easily and give faster reaction. So out of these two, which one will give the faster SN2 reaction? Which will be easily replaced, I or Cl?
Sir, I will be replacing.
Your sound is coming very low, Tanmay. Very, very low. I'm not able to hear this anything.
Might be some problem in the mic, sir.
So I is better leaving group, so it will give faster reaction. So see the answer. Iodine is better leaving group because of its large size. It will be released at a faster rate in the presence of incoming nucleophile. Now, question number 10.7. Predict the order of reactivity of following compounds in SN1 and SN2 reaction. This is the 4-isomeric bromobutane. So, these are the answers are there. You try by yourself. Very simple questions are there that you try. Just to give me a minute. I'm just checking that some more question. Here is the in-text problem is there. 10.7. Which alkyl halide from the following pair would you expect to react more rapidly by SN2 mechanism? Explain. So first pair is this one, and they are talking about SN2. So which one will be faster?
SN2 first one will be first.
First one will be faster. Why? They are asking, explain your answer. Why?
Sir, because the first one is 1 degree carbon, while the second one 2 degree carbon.
1 degree and 2 degree. This is not the carbocation. In the SN2 reaction, no carbocation. Okay, what about this one? Second and this one? Second one. Which one will be faster?
Second one, the first one will be faster.
First one will be there. Because what region?
Because first one is 1 degree, second one is 3. First one is 2 degree, second one is 3 degree.
Okay. Now go for the third one. Third question. See this one.
Third question,
The
sir.
branching is at what? 1, 2, 3 carbon. And branching is at second carbon. So this is the proper attack will be possible. So this will be the order will be the first one is the faster than the second one. Okay, that you memorize. Try to understand. Backside attack is possible. In which one? First one backside attack is possible, but in the second one, backside attack is not possible. Why? Because branching is very close. Suppose if because here is the backside attack, they have to do this one. They have to do this one. So if you are attacking from the nucleophile, you try to attack here. So bond is there. But if a nucleophile try to attack here, easily it can attack. So the faster is like that. Okay. Now question
Okay.
number 10.8. 10.8. Read the question.
Following pairs of halogen compound, which compound undergoes faster SN1 reaction?
Uh, which one will go
Faster.
faster? Which one? The first pair is this one. Which one will go faster SN1 reaction?
SN1.
Hmm.
SN1 means
SN1 is 3 to 1. SN1 reaction
uh,
means
in the case of first question, the first compound will go faster SN1. And in case of the
why?
second one,
Region,
first
region, 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 region.
sir, because in the question number one, first compound is a 3 degree carbocation. And sir, in
3
question
degrees,
number
so
two,
this one. Hmm. What about the second one?
because the first one is 2 degree, but sir, the second one is 1 degree. So sir, that is it.
Hmm. So this is the first one again.
Yes, sir.
Okay. Let us check the answer then. So here what you said, this is 3 degree correct one, then 2 degree correct one. Okay. Here whatever you answer, that is almost all are correct. So this is okay. So you understood the SN1 and SN2, yes or no?
Yes, sir.
Okay. Now we are going to have the example of SN1 and SN2 reaction. So there is a list of many reactions are there that we are going to understand. One side we are writing SN1 and another side SN2. Suppose this is the SN1. SN1, example of SN1. Examples of SN1 reaction. And here is examples of SN2 reaction. Examples of SN2 reaction. Okay. Are you getting my point? Hello.
Yes, sir.
Hmm.
Getting.
Okay. So suppose I am having
Getting, sir.
the, okay, Rx is there. Otherwise you can write in the different form. Suppose I am writing this one and you are treating with the NaOH. So this is 3 degree alkyl halide. So what it is going to give? It is going to give this OH plus it will be the NaX. And here is the compound is what is there. This is Rx is there, 1 degree. So if you are treating with the NaOH, so it will give what is ROH plus NaX. So this is 3 degree alcohol. So in SN1, 3 degree alcohol is forming, and SN2, this is 1 degree alcohol. Can you understand this one? Hello.
Yes, sir.
Hmm. Now another question you see, the same one, 3 degree alkyl halide. This is what 3 degree alkyl halide. So 3 degree alkyl halide, and if you are treating with the H2O, so what it is going to give? Here it is going to give OH plus side product is HX. And here if you are talking about Rx, this is 1 degree alkyl halide and treating with the H2O. H2O. So what is going to give ROH plus HX. Third one, 3 degree alkyl halide is treating with the NaOR. NaOR. So what it is going to happen, this one is going to be out. So what the compound you are going to get here, this is the O and R. And here is if you are having Rx plus NaOR, this is out. So it is the ROR. This is what is there. This is ether. What is degree of ether? 3 degree ether. And this is 1 degree ether. Can't you understand this?
So I can understand.
Okay. So we are making some more compound. Suppose we are having the X and treating with the NaI. So can you guess what the product will be? Can you write this one?
No, sir, not able to understand.
This is the iodide exchange, na? This is the iodide exchange.
Then that will
Finkel,
I plus NX, I plus NX.
Finkelstein reaction this is. So this is I plus NaX. Similarly, Rx is there plus NaI. So this is the Finkelstein reaction. So it will give Ri plus NaX. This reaction you already know. Now we are treating with the, see, this is compound. Again we are taking the 3 degree. This is X plus, we are writing NH3. So what it is going to give? This one NH2 and one hydrogen and halogen will be out. If you are taking Rx and here is NH3, so one hydrogen, one halogen will be out. So it is the RNH2 plus what is there? HX. Are you getting this question or should I elaborate that one?
No, sir, I'm getting.
Here is RNH2 if you are taking. So one hydrogen, one halogen will be out. HX will be out. So what it is going to give here, Sanoy, this is the 3 degree. And here is what is left out. What is left out? So one hydrogen got. So NHR, this will be NHR. Now, similarly, if you are talking about 1 degree, if you are taking and you are treating with RNH2, so what the product you are going to get? HX will be out and this will R2NH will be coming. Now the next one you see, there are many example are there. This one here is RNH2. No, you take the R2NH. This is the R2NH. So what will be there? This X and this H will be out. So what the product you are going to get here? This one will be the NR2 plus HX is out. Here you see this is the RX plus R2NH. So this X and this H will be out. So what will be there? R3N is obtained plus HX is out. This is there. Next one you see. This is the plus R2NH is there. You take with the KCN. So it will give the, if I will write this one, so RCN is going to come plus what is being left out? KCN. KX is out. Similarly, if you are taking RX and you are treating with the KCN, so this is going to be RCN plus KX is out. Many examples are there. See, here is the X and you are treating with the AgCN. Okay. So what is there? This is going to give, this is the NC plus AgX. Both are the very important equation. This is Rx plus AgCN. I will explain you why it is happening. So it is going to be RNC plus AgX. 4, 5 more are there. You keep writing if you are writing. Otherwise, you keep watching if you are not writing. So it is the
Sir, I'm only
KNO2.
not.
Okay, but it is I am elaborating and I am explaining 3 degree and 1 degree. I am making it. Otherwise, we
Okay.
can.
Once you are completed writing, then I will write. You give me 5, 6 minutes, I can.
Okay, this one KNO2 is there. So the product will be what will be? This is the NO2 plus KX. Okay. So here, if you are taking Rx plus KNO2, here if you are taking KNO2, so it is going to be RNO2 plus KX. If I will take you AgNO2, suppose this one X plus it is the AgNO2. So what is there? This compound in this case, wait, Sanay, here is the problem is there. This is the going to be ONO, and here is also going to be ONO. I will explain you why the different one is coming. And here is this is now this is the this is the NO2. In this case, it is an NO2 plus AgX. Here is there Rx plus AgNO2. So in this case, it is the RNO2 plus AgX. This is there. Up here, student, this one, this is the X plus you are treating R C double O A G. So what is the ester is going to form? This one. So this is the double O C R. This one. C double O R. This is correct. Now if you are taking the RX and R C double O A G. So this one is going to be out AgX plus here is AgX is there. So this is type AgX is there. Plus what is the product you are going to? R C double O R. You can write the same formula here also. There is no problem. There is R C double O R. This is possible. Either side is possible. Last one, you two more are there. Here is X and LiAlH4. This is there. And you are treating, then it will give what? This is the hydrogen will be coming. And side product not required in this case. Similarly, if you are treating this one, Rx and LiAlH4, so it will give RH, alkane will be forming. Last one, here is the X plus they are saying, here is suppose RMGX is there, RMGX. So what it is going to be? So it will give the R. Here is the, again R will become plus MgX2. MgX2 will be out. And here is Rx plus RMGX. Here is, what is there? RMGX. So what will be there? This one is out. So what is there? It will R dash R plus MgX2. So this is the example of SN1 and SN2 reaction. You may find very difficult because I write 2 times. It was supposed to write only 1 time, but I separated only 3 degree. Here I degree separated, na 3 degree. So if it is 3 degree, so it is example of SN1. If it is the 1 degree, this one, the example of SN2. Same reactions are there. Only the difference is what? Degree of halide, degree of alkyl halide. Can you understand this?
Yes, sir. Sir, now I need some time to write this.
You can take time, no problem. Otherwise, you can take the screenshot also because it is taking time.
Sir, you can you sir take this photo for this and send me, sir? I am doing the tablet, so the screenshot will be a bit difficult. So if you could take a photo and send me, it would be very good.
But how it will not come, na, this one. Otherwise, you can take a screenshot also because it is
Okay, sir. One second.
wait. I am taking the screenshot.
So you take the
Just
screenshot and send me.
just give me a minute. Now the I shared this one on your WhatsApp number. You can check that one. So, no. Okay. So you might receive that one.
Okay.
Ah.
Got it. Got it.
Hmm. So, but you need to make a note of that one. Otherwise, it will
Sir,
very difficult.
I will write right after your class.
Okay. See the question. Question number 1. Why they are saying why the products are different? Why the products are different? Products are different. Different when Rx is treated with Rx is treated with Rx is treated with which one? KCN and AGCN. Getting why the product are different when Rx is treated. Rx they are going Rx plus KCN. Rx plus KCN. So it is going to give RCN plus KX. And second one Rx is there. It is treated with AGCN. It is giving what? RNC plus AGX. They are saying why these two products are different. What is the reason here? RCN and this one RNC. Can you tell me? Hmm?
Mm, no, sir.
So,
This one I cannot.
yes, KCN. KCN is ionic compound. What compound? Ionic compound. Ionic compound. KCN is ionic compound. So if ionize it one, so then it will give K plus and Cn minus. So negative charge is on. Negative charge is on what? Carbon. So it attack with carbon of Cn and form cyanide. and form cyanide. Cyanide. It forms cyanide. This is the case one. This case one. Now you see the case two. In case of AgCN. See, this one according to Fajan rule, this is the covalent compound. Covalent. Covalent compound. So does not ionize. So does not ionize. It is not going to ionize. Does not ionize. Ionize. And hence they are saying, and hence attack with attack with attack with lone pair electron of nitrogen. So it form isocyanide CANID isocyanide. So what is happening, you see, this one in the form, this is present in the form of cyanide ion. So yeah, if I will write that is CH3X, so here is the backside, it will attack Cn minus ion. With the carbon, it is attacking here. So what it is going to give? CH3 Cn it will give, plus it will X is out. But in the second case, it is the AgX is there, AgCN. And this AgCN is, you must be knowing, this is covalent compound, AgCN. And if you are treating with the CH3X, so this carbon, not carbon, nitrogen is attacking. So what is happening here in this case? It is forming what? CH3NC, because it is NC plus AgX, CH3NC plus AgX. Can you see? Can you understand this one?
Writing, sir, writing.
No, understanding is important. Do you understand or not?
Yes, sir. I can understand.
Done, sir? No?
No, sir, last study. Done, sir.
Hmm. So the answer you need to keep in mind. Okay. Is the slide is visible to you? NCRT book. Is it visible to you? Book is visible.
Yes, sir.
Okay. Can you read the example 10.5?
Hmm.
Hmm. Read it. How you are reading? I am not able to listen that anything.
Okay. KCN is predominantly ionic and provide cyanide solution of the both carbon nitrogen are in the position to donate electron pairs that act express mainly to the carbon atom and not through the nitrogen atom since C bond is more stable than CN bond. However, AgCN mainly covalent in nature and nitrogen is free to donate electron pair from ice forming isocyanide as the main product.
Can you understand this?
Yes, sir.
KCN, they are saying this is ionic. So it will give the cyanide ion, Cn minus, negative charge in the carbon. But here in Ag, however, AgCN mainly covalent in nature, and nitrogen is free to donate electron pair, forming the isocyanide. So in the AgCN, the attack is from the lone pair of nitrogen because it is not going to ionize. Okay? Yes or no? Hello?
Yes, sir. Audible. Sir, sometimes your voice is getting just off. I cannot hear it. Like totally
Acha,
blank, and then sometimes it is again coming.
something is problem is there. I don't know. Here you see, similarly, nitrite ion also represent an ambidentate nucleophile. Ambidentate nucleophile means nucleophile in which two sides attack is possible. One side is carbon, another side is nitrogen. This is ambidentate. Similarly, nitrite also represent ambidentate nucleophile to different point of linkage. With the KNO2, it is ONO, the linkage through the oxygen result in alkyl nitrile, while in the nitrogen, it leads to nitroalkane. So let me explain here. So if you are taking the KNO2, KNO2, it is appear like that, but it is how it is the KON double bond O. This is the KNO. And AgNO2 means AgNO2 is similar. You can represent Ag. This is the N double bond O coordinate bond O. This is actual structure. Getting my point? Actual. So the first one when it is ionized, it will give what? K plus ONO. So this will be the minus. And the second one it is going to give what? Ag plus suppose, and it will give NO2. So this is lone pair. So if it is the K, so how the product will form? Rx plus KONO. So what the product is? RONO. Okay, plus KX. And another one, Rx is there, and you are treating with the AgNO2. So what it will there? RNO2 plus AgX. Here you come back. You see these two lines. If the KNO2 is there, so it will be ONO. AgNO2 is there, so RNO2. Can you understand this?
Yes, sir.
If the compound is covalent, so attack will be from the lone pair electron, nitrogen. And if the compound is ionic, so it will be the it will attacking with the oxygen. Do you understand this?
Yes, sir. I can understand.
Okay. So now this chapter is 50% completed. 1, 2, 3, 4, 5, 6, and 7. Means it will require 4 more class. Today, if, now I am not teaching you more because it will be difficult for you to digest all. Okay. So what you do,
Okay.
this all the reaction, whatever the reaction I told you, this all the reaction you memorize. Along with the region I told you, this 110.5, this region, AgNO2, KNO2, with the exception, and difference in the SN1 in the SN2, difference. SN1, SN2, SN1, SN2. Okay. And the thirdly, mechanism of both, mechanism of SN1 and SN2. You memorize this one, SN2, SN1. Getting my point? Hello.
Yes, sir.
So you please do this much. All the reaction, whatever the reaction I told you today, reaction, second difference and mechanism. Three things memorize. Night time, if possible, you confirm whether I am free or not. So if I will be free, I will be teaching you like 10 o'clock or 11 o'clock. Till time you just go through it. Some problem, exercise problem also you can try. I am showing you some problems are there. Complete the following cases. What are the problem here you see? Uh, just give me a minute. There will be some problem are there. Like this compound is there, 10.9. So this one you can try. We'll see you in the evening time, night time. Na?
Okay, okay.
I am not teaching more because you need to memorize that. That is why. Otherwise, I could teach much more. I will ask you only questions. The question session will be there. Question answer in the evening time.
Okay.
Question answer only. So whatever I taught today, you keep perfect in that. Be perfect in that.